journey in time from the history of AI all the way to the future of AI. So seatbelts on, let's get started. So a little bit about AI. A lot of you might have heard of this guy called Alan Turing. Oh my God, let's see if this works. There you go. Sorry, let's not talk about me. But just hoping that this works. Okay, so today we're going to talk about the 1950s all the way till today's world, and then we'll talk a little bit about what's on the horizon for AI. So there's this guy, this very handsome guy called Alan Turing, incredibly intelligent, and I guess he is the person who pioneered what artificial intelligence is today. Very importantly, he created this thing called the Turing machine. And the Turing machine, well, it was this really, really large, chunky machine. But more importantly, what he created was this thing called the Turing test. The Turing test was basically the idea of, how much can a machine exhibit human-like intelligence? And so even today, the Turing test is where we come up with the idea of, is this computer smart enough to think like a human being? And oftentimes we actually talk a little bit about the Turing test as, we say, oh, my phone has definitely it's definitely a Turing machine, because I'm talking to my friends and suddenly Facebook is giving me an ad that I was on the subject I was talking about. So that's one of the things that we kind of liken the machine to human-like intelligence. Of course, the Turing Award is the other thing which a lot of people know Alan Turing for. The Turing Award basically is the Nobel Peace Prize of computing. People attribute the best contributions to the field of computer science and technology and award the Turing Award as a yardstick of contributions to science. Of course, this is the boring part of the presentation. It gets more interesting as we go along. But look at the machines that you see in the slide. They fill up the entire room, right? So this is the 1950s. This was really where AI started as a concept. By 1962, there was the first AI program which was already starting to run. Arthur Samuel on the right, he starts his first AI machine, and this basically was the machine that helped to teach rote learning and generalization. So when we talk about it today, we're talking about Excel filters. But in those days, you needed an entire room full of metal in order to run an Excel filter. So this is the history of AI, where we were trying to structure and make sense of data. For many, many years, people have been thinking about data. In fact, so I'm going to go through this very quickly. John Holland was, the guy who came up with genetic algorithms, and these algorithms were supposed to help us talk about problem solving. So he wrote the first neural network. So what is a neural network? It's basically how to link data and associate data with outcomes. So basically, it's labeling a piece of data and saying, okay, if the prices of milk are a particular range, that is how we contextualize data, right? So what is the value of money? How do I use the value of milk to understand what is the affordability index of an entire population? So evolutionary computing with John Holland was really to talk about how do we contextualize data. So we have this thing called problem solving, right? So and a lot of it was pioneered by Carnegie Mellon University, where I still teach in Carnegie Mellon on artificial intelligence, ironically. And you know, we now talk about how do you solve problems, but what are the real problems? We have to define problems very carefully. So one of the first things that we teach in computer science is about solving problems, but defining problems carefully and then using experimentation to solve puzzles. On the left, you see two guys playing chess, right? So um, today, the AI that is available in market has beaten the grandmasters in chess, right? So now the grandmasters of chess no longer can beat AI because you know there's so many rules in chess, which unfortunately it's very hard for a human being to remember intuitively all the rules. But really, big data is not new. Look at this picture. In fact, the Alexandrian library in 300 BC, they were trying to compile all the data and contextualize it. So really, you know, it's not something that happened in the last 20 years. It's not something that happened in the last 50 years or 70 years in 1950. It's been around for you know thousands and thousands of years, and people in the Roman Empire have been attempting to examine military data so that they can fight their best wars and conquer the most amount of land and so on and so forth. So really, big data is not a new concept. It's something which basically makes sense of data in all its forms. Notably, you can see people in the picture, they are reading scrolls. And in those days, we had scribes and people who worked in the libraries. Today, a person would use technology called optical character recognition, or OCR, to read this data, script, handwritten data, and contextualize it using what we call a data schema. So, of course, in the 2000s, as we come up to modern days, we will see that a lot of data has been measured, but only 2% has been saved, retained, or cached. And that's already 64 trillion gigabytes. That's the amount of data there is in the world today that has been, you know, I mean, in the world today in 2020, it's 64 zettabytes worth of data. However, we only save, retain, and contextualize 2% of that. And that was in 2021. So we had three generations of big data, right? So the first generation being database administration, people were trying to just store data and save data. And then we decided to say, okay, maybe we want to do analysis, right? So we did analytics and we tried to analyze data. A lot of times in big data in the early 2000s, it was really just about saying, okay, if this, therefore that, what is the context? But today, we have big data phase 3.0, and that's actually more second order analysis. And what does this mean? So second order, third order, and multiple orders analysis, it basically is saying, if I take that data, what does it say about something else? Say, for example, behaviors. If a person keeps buying a lot of milk over a short period of time, it might mean that a newborn child has come into the family, and therefore it means that this person might be at a specific life cycle or life stage. If a person goes to a specific mall all the time, it might be because it's near that person's home, and it has the mixture of vendors and stores that that fits the person's demographic. So that's actually what we're doing right now with contextualizing data in a different way, in the sense that we are doing second order, third order analysis. What does it mean for all of us, right? So it means that if you go to a hospital and you're ill and you cannot speak, essentially, you might be able to walk in and they know who you are and treat you immediately without you lifting a finger. That's how contextualized data can open up a lot of possibilities and opportunities for you and me collectively, right?
Yep.
So now the question is really, what's next for big data? What do you think we want to do? So now we've started to contextualize data on a second, third, fourth order. Now the question is, what's on the edge? And the thing about edge data is, it's basically the idea of what else is there. We are looking at how data is going to be managed, it's processed. And we're also looking at cases which are not ordinary. So edge data typically is edge use cases, things that were not expected. So there's a lot of anomaly tracking. For example, right now we see a lot of research going into, or rather big data and AI projects going into COVID analysis, post-COVID analysis, right? So how many people took what vaccinations, and how many of them actually got COVID regardless of having the vaccinations? What are the reinfection rates? What are the pulmonary diseases that have happened since such vaccinations, so on and so forth. So this is kind of what we're seeing a lot of. And then, of course, everybody's going to ask me about OpenAI and the infamous ChatGPT. Not sure if I should say it's infamous or famous, because you know, I'm also an academic. I teach in school a lot, and my students use ChatGPT to write their dissertations and thesis. But in fact, I encourage them to do so, because if they don't read their thesis, it kind of shows up quite quickly. So what is OpenAI? OpenAI was a company which tried to bring this thing called artificial general intelligence, or AGI, to the mass market. So basically, artificial general intelligence is the ability to perform human-like tasks, repetitive human-like tasks, but at scale and at speed, right? So that's basically what AGI is. Funny enough, AGI became GAI, which is generative AI. And so it's basically, GPT means generative pre-trained transformer models. So it's a way in which you transform data into a lot of data into a contextual answer. It's exactly the same thing as you would see in Google, only in a chat format. So if you're wondering, it's not a big deal to a lot of people, because GPT-3 trained about 100 million data points. And if I am not wrong, the current GPT-4, which just came out, was, I think, 100 trillion data points. So it's starting to grow in scale, and a lot faster. Since the acquisition by Microsoft, they have had access to free cloud, which really, really reduces the cost of training the models. But remember this, okay, anything you search on ChatGPT is for data up to 2021, 2022. So it's not updated, but in 2024, anything that happened last year is not in ChatGPT. So if you ask them for current information, or if you ask ChatGPT for current information, you might not get it. So that's something that you guys should take note of. Of course, why is OpenAI super well known? One of the biggest things is that it actually had, if you look at adoption of technology, it took a couple of years for Facebook to acquire 5 million users. It took Twitter a lot less, Instagram a lot less. And then, of course, we went on to Threads, which was a Instagram phase, I guess. And then we have ChatGPT. It took 5 minutes for them to go to 1 million users. 5 minutes. So that's how quickly OpenAI had adoption. And it was revolutionary for many people. They saw their the questions answered in a very conversational style. And I guess one of the biggest things was the UI, right? You can see ChatGPT typing it out for you. So I think the user interface was really fascinating. And I think that was the key to their popularity. But really the answer to it was that it provided access to artificial intelligence on a mass scale and at a very low cost. My ChatGPT bill every month is like maybe $2 or $3 US. So it's really very accessible. Whereas for a lot of SaaS solutions out in the market, you're paying at least $10, and it doesn't do half the work that ChatGPT can do. So there you go. It's got 25 million daily users. It's got 175 billion parameters, and it has a pretty small data set. If you say 570 gigabytes data set, that's a couple of trillion. So for context, in the US market, we handle 42 trillion lines of data, and that is about 883 gigabytes of data. So that's kind of the amount of data that we're handling right now. So we're going into Pop AI. So we went from Gen AI, we're going into Pop AI. And so this is where things are starting to get interesting for us. So we're actually in the top line. So if you look at generative AI, that's kind of where we are. We're going to go through a couple of these concepts as to how AI is going to start moving along. And all of these are, if you notice the mountains here, they're all in different heights, right? So a lot of them are not going to be as popular or as important, but of course, as we go along, you'll see them grow in applications. So pre-trained models, which is fueling the generative AI, but now at GPT-4. We're also starting to see GPT-5 take shape. So 4.5 is almost out now, if I'm not wrong. So what is the meaning of GPT-3, GPT-4? It's actually OpenAI's milestones as to how much data is being processed. So the more data has been trained into their model, the more they will increase their model into GPT-4 and so on and so forth. Now, the word GPT to an AI practitioner, it rubs an AI practitioner in the wrong way all the time, because when you say, I own GPT-3, a lot of other AI practitioners will say, the word GPT doesn't mean you own it. It's not a a trademarked concept. So generative pre-trained transformer models have existed way before OpenAI. But so they trademarked their numbers, GPT-3, GPT-4. So those are the trademarks that they own. So for purists like myself, we get riled up whenever somebody says, oh, somebody owns a GPT. So just fun fact for you. But really, you'll see that deep learning is going to start growing. So deep learning can be applied to a lot of different things. For example, computer visioning. We're using computer vision right now to process 10 million receipts a day for healthcare providers across the globe. We are able to do computer vision for crops. For example, in Thailand, where I'm in right now, we look at crop yield, diseases in the crops, as well as predicting when exactly a harvest is completed, so that there is no degradation of the crops. So computer visioning could be used for a whole bunch of applications, from crops to security to environmental monitoring, all the way to receipts, unstructured data, reading doctors' terrible handwriting, so on and so forth. Natural language processing is something which we're quite familiar with, I'm assuming. But a lot of people are starting to build their own private large language models. The one thing which I find very interesting is speech recognition. In earlier applications of healthcare, in the healthcare setting, people were talking about speech recognition to so that doctors don't need to use natural language and type in their prescriptions, and they lose time and clinical acumen. So we've seen a lot of ambient AI, which means a microphone sitting in a doctor's office to take in information about the patient and what the doctor wants to do. What we are seeing now is that the ambient AI is able to detect slurring and diagnose very quickly things like ischemic strokes and the like. So you see that there are now evolutions in even speech recognition. The easiest way to talk about speech recognition is Siri and Alexa, right? So all of us have used Siri and Alexa, but now the applications of speech can be in security, as well as healthcare settings. Autonomous systems, we all freaked out when Tesla had its first self-driving car, or Waymo had the first self-driving car, but it's incredibly important to have autonomous systems. Why? Because we are able to deploy drones in war zones, and that actually is useful because that prevents loss of life. But drones are useful as well in inspections of massive scale, right? So we work with agriculture, as I mentioned, in Africa. So in Africa, it's hundreds and thousands of hectares, and you need drones to fly over set paths. We have robotics, which, as the global population ages, we're able to use robotics to perform a lot of the work that we ourselves will not do. Edge AI and IoT, it's basically using sensors and stuff like that to help drive outcomes, understanding where your product is at any time. It's also good for security. Knowing where your son is when he's in a grab might be useful. That's where we use Edge AI. Gonna talk through AI democratization, and I think it's really the fact that today AI has been trained in so many ways that it's so important to democratize. It's getting cheaper to create your own large language model. It's getting cheaper for you to create a lot of AI solutions. In the early days, when I first created my first segment, it took me 2 years to build my first AI SaaS solution, and it cost hundreds of thousands of dollars. Today, creating that exact same solution from scratch takes me about 2 to 3 months, and it cost me less than $50,000. So for context, AI democratization is incredibly important. And of course, we are seeing a lot of AI applications in critical industries like healthcare, defense, transportation, and finance. So you see a huge shift to industry-specific solutions these days. When we talk about healthcare or fintech, you see a lot more industry-specific solutions. For me, a little bit of a tip, if you're planning to go into artificial intelligence, think about functional AI, and that's where my specialization lies. Today, I see a lot of very industry-specific solutions, but really, there are some functions that cut across every organization in the world. Let's talk about sales. Can we use AI to drive sales? Can we use AI to drive financial auditing? So some of these very functional, specific solutions have not been explored, and I think that's a huge opportunity for everybody. And so kind of where is AI going? The most important thing that I'm gonna say about AI is that people are scared, and that's going to really pause the development of AI. People are scared, ethical concerns. Data quality is starting to become worse because people are creating what we call synthetic data, right? So they're creating, how do you know whether data is true? A lot of data today is actually fake data, right? It's synthetically created data. And how do you validate and fact check all data? Also, we're running out of AI talent. No matter how much I teach AI in Carnegie Mellon, I don't think I can produce enough AI engineers to meet the world's demand, at least in the short term. And of course, the cost of implementation of AI is starting to get bad. So the new innovations, this is the exciting part, where I talk about some technologies which are starting. So these four, I won't go through them in detail, but vectorization, streaming, graphs, and explainable AI, these four items are really starting to develop in a big way. In Asia, data vectorization is not a big deal, a big thing. We don't see a lot of it coming to Asia. So the company that I built actually specializes in vectorization. Actually, these four, we specialize in the first three. So that's kind of what we do. But what is vectorization? It's basically creating an outline of the data and basically pulling the most relevant and impactful data to be able to create a single instruction, multiple data solution. So basically, it's creating parallel data, the same data on parallel applications. Data streaming is like live streaming, so it's all live data. So what is it useful for? Healthcare, obviously, you don't want past historical data when you're walking into emergency room, right? So another thing which is important would be payments. You want your payments to be received immediately. Graph neural networks, the word graph basically means relational. So what is a human being's relationship to a physical building, to a brand, or to any form of data? That's what a graph is. Of course, explainable AI is so important because a lot of us don't actually know what AI is. So having explainable AI will help us foster collaboration between humans and AI. So, like I mentioned, more than ever, people are afraid. People are more concerned than excited, if you look at this graph, right? So this is conducted in 2023. People are concerned. So how is it going to impact us as human beings? Number one, things are gonna get faster. We're gonna dance way, way, way faster, and it's gonna be a disco. Nobody's gonna be slow dancing and waltzing on the dance floor anymore, unfortunately. But that's unfortunately good and bad, right? So you get more information faster, you get more applications faster, governments will be held more accountable. Businesses will be required to have more personalized care of their customers. But from a person-to-person perspective, things might feel a little bit exhausting, okay? Our privacy, I hate to say it, no matter how much we have the PDPA, the amount of spam that goes through my inbox every day is not helping, right? And the more you unsubscribe, it seems like the more the emails come. So privacy is a huge problem. And I don't think we've solved it yet. Our data is still being sold to different people. There's been a huge movement for legislation to take place. Unfortunately, everybody who wants to make the law is a practitioner of AI. So you can't get the criminal to make the laws, right? So That's something which we've noticed there's a huge conflict of interest there. But really, there will be a lot more human and machine collaboration moving forward. So that's something which we see, rather than replacing human labor, AI is going to help drive a lot more outcomes for human life and living. So that's it. I apologize that it was a long presentation. I tried to keep it as short as possible, but I hope that gives rise to a couple of questions, and I